Hello, everybody. In this session, I will present my vision to the cognitive era. The vision is merging the Internet of Things with the cognitive systems for a new era where all the Internet-connected systems are cognitive. So it is a complete vision that contains a lot of innovative ideas. I hope you will like it and benefit from the ideas it contains. The science and technology are the tools for human prosperity, as you may know. The enterprise that has the best and long-term vision of the technology can set the best technology development roadmap and hence can lead the market. To do this, you have to study the current technology and imagine the future, then set the appropriate, realistic roadmap to reach it. Let's start here with first reviewing the current technology in terms of the system communications. Nowadays, communications between a human-driven system and a repository system, as example in form of queries or writing using specific commands like select, insert, update, and so on, or between two generic applications. It would be also in form of predefined set of requests and response, like measure the speed, calculate the selling price, add the new city to some calculations, and so on, etc. This is the type of the form that will known today's in system communication. Now let's summarize the characteristics of the current communications technology. It's characterized by a deep technical message format, where it is a general IT level message structure like the WSDL, API, JSON, IDOC, and so on. And also system-specific or business-specific message structures like Swift or ISO, etc. Also, it's characterized by deep technical service or function, like it indicates inflexible list of actions confined to the IT processing capability of the system, like the get and set update for repositories and add and edit and remove, measure, calculate, queries, and so on. It's also characterized by that the caller system has to know the format and service catalog of the call service at design time and vice versa. There is a little exception for some systems to can dynamically change the names or search for the services available in system in the catalog and so on. It's also characterized by no dynamic behavior at runtime, and so no autonomy. Always there's needed, a middleware is needed or required for centralization of the transformation, routing, and protocol conversion. So this is the characteristics of the current communication between systems. Let's move to the next slide. Now going to the target or the targeted technologies part. How can we imagine the new era of cognitive systems? When a normal human starts talk to another human, they use high-level statements that are common to humans, like greetings. Then they would use more specific statements gradually. So there is a level of speech that is common to and understandable by almost all the normal humans. The lower, the specialized or technical level, would be any of the wide range between the greetings and the very specialized details of the two sides. the speaking side and the listening side. Specialized in a common profession as example. So the closer the profession of the two sides, the lower the level of the speech is. Lower in terms of technology and specialty and so on. So to be as close to the human behavior as possible, we need to have autonomous system with distributed intelligence. Okay, moving to the cognitive era society and the Internet of Cognitive Things society, how we imagine that. Then what are the details of the targeted vision? These details, here I'm describing the cognitive era society. It's the Internet of Cognitive Things in terms of how we are networking things together and how things will communicate with each other. There's a network of smart nodes. We imagine it as a network of smart nodes. A smart node might be human, a smart car, a smart device or instrument or machine, or a smart database storage or a smart application and so on. The word smart means there's some intelligence, distributed intelligence in what we call. Each smart node has a unique ID on the network. Each smart node is represented as an employee whose personal information would contain the name, as example, for only for the human smart nodes, and the type for the other systems, the role of each smart node, the position, affiliation, location, XY location, and so on. Moving to examples of the communication, such scenarios, providing here, or I'm providing here as examples to the communication in the cognitive era. Let's now take a sample for different systems, smart nodes, leaving the description of how the technology will implement that to later charts. The first sample is between a human smart node and another smart node that represents an ERP as example, ERP system in an enterprise. The communication starts by the human node, which represents a sales manager in the enterprise. The sales manager speaks to the ERP system and say, as example, "Good evening, ERP system. This speech makes the human smart node, the device that receives the speech of its own, detects the smart node targeted by the speech. So the smart node will define or will detect the target smart node from the speech as the first statements that he will speak, and maps the name to the actual address of the targeted smart node. The second thing is that the ERP smart node gets the message that in turn initiates its authentication component. If the authentication passed, the ERP system reply to the speaker with his name, and saying, as example, "Good evening, Jane." Then Jane, if he is the speaker, requests a service from the system by asking it how much is the selling amount for today. The ERP system runs the needed functions to get the results, then reply to the manager in natural language, saying that sales amount is 25,000 for today, as example. The manager says, "Thank you, ERP," and this is a statement for closing the call or the session between the two smart nodes. Let's move to the second communication sample, which is among the ERP and other software applications of the enterprise. The ERP addresses the non-human smart nodes in the enterprise and makes a broadcasting a request message. The request message says, send me any changes in customer data for today. For example, broadcast to all the non-human smart nodes in the enterprise. The ERP smart node gets the first response from, as example, the CRM system. The CRM system says or responds with changes, please attach it. Then the ERP system addresses the SMS system of the enterprise and ask it to send messages to the attached list. And the message is telling them or saying thank you for your kind visit. Then the ERP broadcasts to all non-human smart nodes again, which of you has the customer record of the customer Sandy Martin. Then a response comes to the ERP from the IVR system, as example, this scenario says. And the IVR system, smart system, says, I have it, and find it attached in the response message. Then the last sample of communication is between the JAME, the human smart node, the manager, and his smart car. JAME speaks to his car saying, good morning, my car. The car authenticates JAME, then replies, good morning, JAME. JAME requests a service from the car by saying, please start engine. The car smart node starts the engine and replies to JAME, engine start, done. You are 30 miles to run out of fuel. All car status parameters are normal. Then moving to the next slide. Now moving to how this vision is going to be implemented, or what the technology collection used in the implementation is. Starting with how a human smart node communicates to non-human one, here in this slide. A human smart node contains many components for the natural language processing, like the speech recognition and the text-to-speech. When a human smart node initiates a communication with a non-human smart node, his smart node converts this speech to text via the speech recognition component. Then the text is converted by the text to standard smart message. This is a component called text to standard smart message, converts the normal text, unstructured the text to the standard smart message. This component converted to a format proposed by the vision to be the single message format. This will be the single message format on the Internet of Cognitive Things vision that we propose. The human smart node generates a standard smart message that contains a field for the audio authentication. So this is binary audio signal. This field contains an audio signal sample in case of the initiation or the initial message that starts the communication session. The audio authentication is achieved at the non-human smart node by speaker recognition component. The speaker recognition component recognizes the speaker and so authenticates it. Once the authentication is passed, the session is established and the smart node replies with a message in the standard smart message format, the SSM format. The human smart node converts the standard smart message to text in form of script of the speech by the standard smart message text by the standard smart message to text component, and then converts the text to speech and provides an audible reply to the smart node owner. The human is now, in case of two human smart nodes, at the session start, the smart node of the receiving side voice authenticates the calling side. After the authentication, the session is continued in voice. And the smart node in this case gives the owner the option to record the conversation in the standard smart message format. There will be also an option in case of conversations pertaining business deals. So this option allows the two parties to securely document the text conversation using the blockchain technology. Moving to the case of two non-human smart nodes. In this case, the conversation language is in the standard smart message format, where no message transformation needed. So because we have a single message format, each node has its own internal message parser for the machine-specific part of the standard smart message payload. The standard smart message can be of no payload in many cases, like the queries and questions, which is in the titles can be sent, many of the message without the payload. Moving to the next slide, let's focus on or zooming on the standard smart message. One of the key elements of my vision here is the standard smart message format. The standard smart message, the SSM, and one of the challenges of the implementation of this vision is with today's technologies and the development of the appropriate speech recognition component that has a vital role in addition to the normal speech recognition role in detecting the sentiments of the speech in order to assist the text to standard smart message component in detecting the message type. The message type, which is different categories as we will list now. The message consists of a message header and a message body. The message header contains message ID, message title, message subtitle, date and timestamp, source, the source smart node, target smart node structures, both, and then the message type structure. The source node and target node are of the type smart node structure. This structure contains many fields like the name. This is only for the human smart node. The audible authentication field, also for human only, where this is a voice signal. The type of the smart node is a field. The ID of the smart node. The location, XY location of the smart node. The affiliation, the company or the institution. The role and the position of this smart node. The smart node type is an enumeration sorry, that will take the value human or metrology instrument, banking application, CNC machine, robot arm, vehicle, home appliance, and so on, based on type. The message type field of the header is also an enumeration of the values. The message type would be one of these lists, which is contains, as you see, information. Is it some message to inform the other smart node some information? But is it a query or question message between two smart nodes? Is it an answer to question or query? Is it an order from a high-ranked node to a lower-ranked node? Is it an action result? Is the reporting from some smart node to managers or to a management committee and so on? Is it an invitation to meeting? Is it a reminder to another smart node? Is it an announcement or broadcasting to multiple other smart nodes and so on? In case of the source smart node is a human one, the message type is classified according to, number one, the sentiments detection and the speech. Number two, the type of the target smart node. Number three, the position of the target and source smart nodes. Number four, the location of the target and source smart node. Okay, moving now to the node governance using the domain name server. As I mentioned before, each node or each smart node represents an employee. For the smart nodes in an enterprise, a server like the domain name server has the enterprise organizational chart in it. The server can resolve and map the smart node names, the smart node locations, and etc. Because it can does this because it has access to the list of the static fields of the smart nodes headers, the static fields in the header of each smart node, the locations, name, the ID, and so on, the type. As shown on the figure, this chart, the organization smart node network would contain human and non-human employees in the different positions in the same enterprise. The DNS, the domain name server, would have a component. This component will be responsible for tracing the conversations between the different smart nodes. As example, the message of the type order, the type order can only be from a message, can come or transformed and transported from the side of a higher ranked node, smart node, to one of the employees or the reportees of this smart node in the different positions, in the lower position. And also a carry-out policy that contains parameters governing how it will be carried out and the time frame of this carrying out of this order and so on. The inverse message from team members to higher level, as example, can be of the type request and not of the type order. As we said, the type order is from a higher rank to a lower rank. Another carry-out policy would contain an optional carry-out flag also that is not mandatory for the receiver to abide with. Note, there is a note that's worth mentioning that a human smart node of a manager position, as example, can send the quarter or the annual business targets translated to his employees, can send them to his employees or his individuals for the different roles and responsibilities targeted in this quarter or this year and so on, for them to abide with it as a plan or a strategy for their work and tasks that required from them. Moving to the next slide. In the next slide, we have just a sample or example of a standard smart message. As we can see in the figure, let's look at this sample. The header important fields are the source smart node and the target smart node. As we see, the source node is of type human, defined by its own name, which is James Edward, his unique ID on the network, its affiliation to the dummy company, which is NCD, as we can read. Also, his XY location. Sensed by this location is sensed by the node internal GPS system, which is some important technology inside the smart node hardware. This role in the organization, which is sales expert, the role of this human node, and his position as a manager. The target smart node is of type retail application. Its affiliation is the same as the same company as the source node, and so on. Going down to the message body, it contains the text of the actual message content. In this case, it's a query, a small query like a question. The question is how much are the sales sum for today? Some summary of the work of the today sales. Let's move to another slide. The software stack of non-human smart node. It's important to imagine how can this smart node achieve this smart distributed intelligence and this smart work. As stated before, the non-human smart node would be a machine, appliance, business application, and so on. For such machines to acquire a high level of intelligence, it must include an intelligence layer of software in the figure called decision-making unit. This layer does the following tasks. This layer, the speaker recognition, it does the speaker recognition for authenticating the human smart nodes. It also performs the translation of the text in the input standard smart message with its embedded sentiments into requests. This translation also to business application part and manage their execution. Translated from the SSM message request to the traditional business application part. Translated to the traditional part of the application. It also prepares the processing results or replies and send them to the standard smart message serializer to generate the SSM to the other side, as in the replies and results. It also in the time periods of no pending tasks, when it doesn't have tasks to reply, and tasks of higher priorities, it reviews the business targets backlog. It has a business targets in the list of business targets for the quarter, for the year, and so on. So it reviewed this backlog of tasks and executes the relative task that can be executed or the due time tasks. In case of it has scheduled tasks to be done in the specific times, so it does or achieve or execute this task on time if it is pending execution. Also, this intelligent part of the stack, of the software stack of the smart node reviews the status of the overall system of the smart node and takes action in case of error reported, error in the smart node as an application, as an appliance, as a machine, and so on. Sorry. This action would be like sending emails, reporting to a human smart node, sending requests or invitations to other smart nodes to meet and discuss a solution to the issue. Okay, let's move to the next slide. The next slide is just some sample use cases for the overall enterprise, a smart enterprise that contains all its employees as a smart node. For my vision to the Internet of Cognitive Things era to be better digested by your imagination, let's imagine a smart organization that contains all its employees as smart nodes on the network. We would see in this organization the following. A new non-human employee in the organization introduces himself to the smart nodes on the network for the registry and on the network to add him. Also then he can broadcast questions to the organization systems. These questions can be on the information he needs for his initialization, like the database connection information, the existence of some services he would need to achieve his tasks, and etc. Also, we imagine in this organization, smart organization, we would see one of the organization smart nodes needs an invitation. Sorry, one of these smart nodes can send an invitation to some other systems to discuss with them an issue it faces and suggest a solution to this issue for it to try out. We would see also in the smart organization a CRM smart node while doing one of its daily work on consolidating the customer database. We would see it to update the golden instance of this database. It can does this role. It can do this role by broadcasting an order at the end of the business day to the other systems that has other instances of the customer database to send him any new records saved in that day. So it can consolidate all the changes all over the day in this database or on the customer database. In the smart organization, we would see also the human smart node of a manager that asks the smart node of the HR smart database about some details on one of his reportees, and so on. So we see the entire smart organization working in harmony through this smart components, this smart nodes system that has or implemented the distributed intelligence in different levels in the organization. Let's move to the last chart. The last chart is some of the operational aspects that can be taken into consideration while implementing this vision. As part of the vision here is on the transformation of the enterprises from a traditional enterprise to a smart One, this vision here is that the intelligent layers can be created in an incremental mode, so that selectable components can be tailored for each system and installed to convert it to a smart node. Also, from the operational point, the created smart node can be operated in a dual mode during a transient period. This means that the traditional mode and the smart networking mode, as we see in the figure in the slide, the dual connections and dual operations can operate in both modes, the traditional node mode and the smart mode. This was the last chart in this vision to the cognitive era that I called the era of the Internet of Cognitive Things, or the IoCT. And thank you for your attention, and goodbye.